Hello everyone. Today's question is about resistor networks, effective resistance and potential difference. Study the circuit diagram below and answer the questions that follow. So we have the diagram right there. And then Roman 1, calculate the effective resistance of the circuit. Then Roman 2, find the voltmeter reading. So let's begin with the first part, calculate the effective resistance of the circuit. So we are going to determine the total resistance for this circuit. We are going to begin by getting the total resistance for this part here. Now, for this part, we have these three resistors connected parallel to each other. So we'll have the effective resistance for this part given us. So we have 1 over R E is equal to 1 over 6 plus 1 over 4. So that is 6, 4 plus 1 over 3. And here the LCM is 12, and therefore 6 goes there twice, plus 4 goes there 3, plus 3 goes here 4, and that gives us 9 over 12. 9 over 12 simplifies to 3 over 4. And therefore, the resistance, the total resistance for this part, will just be the reciprocal of this. Remember, this is 1 over R sub E, and therefore the effective resistance for this part will be the reciprocal of this, which is 4 over 3, or 1 and a third ohms. That is for this part. Remember, this part is connected in series with the 4 ohm resistor. So if I may just draw that, we have the 4 ohm resistor connected in series with the 1 and a third ohm resistor. Now these combined give us 1 and a third ohm. So these two resistors are connected in series, and if they're connected in series, the effective resistance there should be the sum of the resistance. So we have 4 ohms plus 1 and a third, and that gives us 5 and a third ohms. So that is 5.3 recurring. Okay, so that is for the first part. Now for the second part, you're required to find the voltmeter reading. Now the voltmeter is connected across the 4 ohm resistor. In other words, we are required to find the voltage across the 4 ohm resistor. Now one thing, for this system, if we combine these resistors here and get the resistance as 1 and a third ohms, now the voltage across this resistor, 1 and a third ohm, plus the voltage across the 4 ohm resistor should give us the total voltage, which is 4.5 volts. It's also worth noting that for resistors in series, the current across each resistor is equal to the total current. So we are going to first of all begin by getting the total current. So the total current is given as the total voltage over total resistance. So here I'm just applying Ohm's law. So we have the total voltage given here. That is the voltage supplied by the battery. So that is 4.5. And the total resistance we already have here, 5 and a third. So we have 5 and a third ohms. And that will give us total current of 0.84375 amps. And with the total current, we can therefore proceed on and say The voltage across the 4 ohm resistor should be equal to the current across it. The current through the 4 ohm resistor should be equal to the current through the 1 1/3 ohm resistor. The current across the two resistors, that is 4 ohm resistor and 1 1/3 ohm resistor, should be equal to the total current, and that is this. So that means the current we are going to use here is 0.84375, and then we multiply by the resistance, which we have 4 ohms. And this, when multiplied, should give us 3.375 volts. And that is the voltage across the 4 ohm resistor, just as had been desired. And with that, we come to the end of the solution to this problem. I want to thank you for watching. Hope to see you in the next video. Bye.